On July 29, 2026, the United States blocked new imports of foreign-made humanoid robots. The official reason was national security. These machines combine sensors, wireless connections, and software inside a human-sized moving body. The decision also exposed an awkward fact. The robot race has moved beyond laboratory demos, and China's lead is large enough for Washington to notice. According to Omdia figures reported by the Associated Press, roughly 15,000 humanoid robots shipped worldwide in 2025. Unitree and Augibot each shipped more than 5,000. Tesla and Figure shipped a few hundred or fewer. A separate estimate published by Xinhua put China's share at almost 85%. The numbers in such a young market are messy. The direction is not. Chinese companies count production in thousands, while many rivals still count pilots. China did not build this advantage from an empty factory. In 2024, it had just over 2 million industrial robots at work. Chinese plants installed 295,000 more that year, or 54% of the global total. Local manufacturers captured 57% of their home market, up from around 30% in 2020. Long before humanoids became viral videos, China was learning how to build motors, controllers, sensors, and factory automation at scale. A humanoid is a dense stack of industrial parts under a polished shell. Electric motors move its joints. Gears and bearings manage torque and friction, while sensors and computers try to keep the machine upright. McKinsey estimates that China handles about 90% of global permanent magnet processing. It also has large shares of motor, bearing, and power electronics capacity. Suppliers cluster around Shenzhen, Suzhou, Ningbo, and Hangzhou. When a knee joint fails, another supplier may be a short drive away instead of an ocean away. Unitree currently lists its G1 humanoid for $13,500. Its smaller R1 starts at $4,900. That is not the full cost of a useful factory worker. Buyers still need the right sensors and hands, plus software, integration, and maintenance. Even so, cheaper hardware changes who gets to experiment. A university can buy several machines. A factory can test a fleet. A software team can break one, repair it, and try again without treating every fall like a financial emergency. This creates a loop. Dense suppliers lower the cost of a prototype, so companies can build more of them. More machines spend more hours in warehouses, laboratories, and factories. They expose loose cables, weak gearboxes, bad grasps, and other problems that never appear in a staged demonstration. Engineers carry those lessons into the next production run. If that run becomes cheaper and more reliable, more customers will test it. China is shortening the distance between a failure and the next version. NVIDIA offers a useful clue. Its new Open ISAC GR00T reference humanoid combines NVIDIA computing and software with a body made by Unitree. The United States still has enormous strengths in chips, foundation models, simulation, and robot intelligence. When researchers need an available body for that intelligence, however, a Chinese platform is becoming a common starting point. American software may train the brain, while Chinese factories supply the body. Hardware volume is not the same as useful work. The International Federation of Robotics says humanoids still need to prove cycle time, reliability, energy use, maintenance cost, and safety against ordinary automation. American companies have real evidence too. Figure says its robots loaded more than 90,000 parts during a BMW deployment. Boston Dynamics has committed its 2026 Atlas production to Hyundai and Google DeepMind. Tesla is installing its first Optimus production lines. China leads the hardware race today. Dependable factory performance may decide the longer contest. Shipment numbers hide another risk. A company can build thousands of robots before the market discovers which jobs justify them. Wheels are usually cheaper than legs, and a fixed arm is often faster than a humanoid. The human shape makes sense where a workplace was built for people and cannot easily be rebuilt for machines. Stairs, carts, shelves, and mixed tasks create that opening. The winning company needs a boring, repeatable job that pays for the robot. China has connected component supply, manufacturing scale, and places to deploy new machines. That does not guarantee the best robot or the best artificial intelligence. It does let Chinese companies learn through production, while many competitors are still preparing to produce. The humanoid race is usually presented as a contest between brilliant machines. Right now, it looks more like a contest between industrial systems. The country that can build, break, repair, and rebuild the fastest has the advantage. Today, that country is China.